The Institute of Forming Technology and Lightweight Construction of TU Dortmund University is the heart of the collaborative research center Transregio 10. The German research foundation DFG has been funding the research work with the intention to allow the economic and flexible manufacture of lightweight frame structures. Since 2003, leading research institutes of the universities of Dortmund, Karlsruhe, and Munich have been working on that aim. The integration and optimization of new production techniques of the process chain is done at all locations. All results of research can be applied to various processes and products. In the automotive and aerospace industry, the results may be transferred to application. The starting point of the process chain is the production process curved profile extrusion. This is an innovative method for the manufacturing of three-dimensionally curved profiles in one process step. The profile contour is generated by the manipulation of the material flow inside the die. The profile is guided synchronously through the robot-aided handling. This permits a production with high precision. It's possible to extrude profiles with different contours, one after another. For non-reactive cutting of the 3D profiles, a flying cutting device is integrated into the process chain. After handling, the profiles can cool down for further measurements or treatments. Laser markings are imminent scales on the mark components, which are the basis for continuous quality control. Once a measurement of the component or of the scale is performed, it is possible to determine the position of the profile. To achieve this, it is sufficient to read in only one marking of the scale. The Transregio 10 Research Center demonstrates an exemplary way to combine forming, separation, and joining, thanks to an idealized process chain for the flexible production of lightweight frame structures. The lightweight materials used are aluminum and magnesium alloys. After the extrusion process, holes and cavities are made using a flexible machining cell. The cell consists of an industrial robot for the handling and parallel kinematics for the treatment. Here as well, profiles with different contours can be machined very precisely, and features like threaded sleeves can be added. The process is fully automated and nevertheless can be adjusted in the details, at short notice and flexibly. The task of joining technology is to join parts to form assembly and frame structures. In a joining station, the profile is prepared for the actual joining process by a treatment of the inner profile contour. The milling process generates a defined inner diameter and a good surface quality. In the following, the joining occurs by expanding the profile in the joint. The joints as connecting elements between the profiles were produced on modern 5-axis machining centers. In this way, the manufacture of the contour is done as well as the systematic manipulation of the surface of the joining areas. During joining by forming process water, power up to 1000 bar is used. After that, joining by compression is done. The profile is led into a tool coil. Joining occurs within 25 microseconds through an electromagnetic field by form fit, 4,000 times faster than in a blink of an eye. The application of different joining methods is essential for the construction of light frame structures. The selection of the adequate joining process is done with the help of an expert system on the basis of experimental, analytic, and simulation data. Hybrid bifocal laser beam weldings can also be used to join alloys, which are difficult to weld. By feeding an additional material, hot cracks can be avoided. Hot cracks reduce the mechanical strength. For joining of aluminum structures in general, friction stir welding is particularly suitable. This facilitates the welding of components without fusing the materials. The Transregio 10, founded by the German research foundation DFG, creates the scientific basis for resource-efficient, flexible production of lightweight frame structures for tomorrow.